format, simply reusable format. Just remember this only one keyword, reusable format. Then such a playbook is called as, or such a playbook which is written in reusable format, we can call that as a role. Now, a normal playbook and a role playbook, right? A small difference is there. Generally, in a normal playbook, we'll start with a hyphen, guys. So keep in mind a normal play that is a kind of an suggestion coming from the Ansible team says that. So whenever you write a normal playbook which is non-reusable, that means cannot be reused. So please start using an hyphen. So that's a clear indication that that's a normal playbook. So whenever you write a playbook in reusable format, start using 3 hyphens. Clear? Please write this point in your books quickly. A normal playbook starts with an hyphen and role-oriented playbooks will start with 3 hyphens. So whenever you see 3 hyphens, you need to understand, okay, there can be reusability of the code and you can call this playbook in any of the playbooks. So I'll draw one block diagram. Okay, or let's see if I have written here. No. Okay. So MS Paint. So let me open up and write one block diagram. So imagine, let's take it for granted this one. Okay, so this is 1, this is 2, and this is 3. Okay, there are 3 playbooks are there. So I will say this is playbook 1, this is playbook 2, and this is playbook 3. So simple story. In this, the code is written in reusable format. So got it. So this entire block, all the codes are sitting in reusable format. So the codes are written in reusable format. You're going to keep in mind the playbooks are written in reusable format. So let's say this playbook is bothering about something about installation code, generic. This is bothering about removal process. Okay, and this is bothering about some configuration. Okay, so 3 playbooks are there, 3 use cases are written. The first playbook may be installation, second playbook may be removal, and third playbook may be configuration. So now imagine I am writing ahead and I'm writing one more playbook maybe here where I need to write the code for, okay, install and configuration. So what I will do, instead of writing the separate code, so what I'll do, I'll just go ahead and call this, or I will say import playbook 1. Next, import playbook 3. That's it. I'll not write any code, just directly I'll use it because this is written in reusable format. So that means I can say that this playbook has been referred here and this also referred here. Got it? So let's imagine I'm writing one more playbook maybe. Okay, here. Or let's take it for granted. This one, another playbook where my logic is written in such a way that logic, just see the logic, how we're planning. So I'm planning to do a config. So I'll call the importer playbook number 3. If this playbook number 3 is fails, then I want to execute playbook number 2. That is how I write the logic. So the configuration is failing, then I'll go for removal. So that means what I'm doing. So this playbook here it is being called and this is also being called. So the logic looks super simple, guys. So the same playbook is being referred in number of places. In number of places, that means you can refer because they have been written in reusable format. Am I clear about this diagram? So the basic playbooks should be written reusable format. So that's the logic. So please take down this diagram quickly. Take down this diagram quickly, guys. Is it done? Confirm. Okay. So I'll try to minimize this in here. So the syntaxes are varying, guys. Just be cautious. Syntaxes are varying at appropriate places. So we'll follow the latest stuff. So in the latest Ansible version, we are using this import underscore playbook. So let's go ahead and try this. I'm just copying C. I'll open up the Visual Code Studio. So already basic, I mean to say base. Okay, so I'm creating a file now. So this is example number 12 on roles-concept.yml. So paste this. That's it. So here, not like this. So playbook is sitting at. So what is our repository name? Under root account, we have 31B, I guess. 31B Ansible hyphen class. So I need to connect to the server to find what is that path. So 192.168.1.200. Give me a second. Okay, got connected. Say this path, you need to put it there because this is place it is referring. Okay, done. Now here we'll write some playbook which we are planning to import. Okay, so let's keep it like that. So this also. Are you understanding, guys, what I'm trying to do? See, we are trying to tell the computer that this is a playbook where I'm not writing any code. I'm trying to call another playbook here. So the assumption is already the existing playbooks should be written in reusable format, guys. So that is what you have to do. So let's me try one sample, example number 7 or example number 8 on loops concept hyphen past.yml. See, I'm just calling the playbooks, existing playbooks. Example number 9, loops hyphen feature.yml. So that's it. So go ahead and save this. So spelling is incorrect. Loops. So save this and commit it. Sync the changes. Okay, now go to the server side. What happened? Control R, root. Yeah. CD into 31B. Then execute. SH. No, not SH. I need to execute. No, git pull you have to do. Then we need to put the password. So 32B, 31B packed. So this is the one. Copy this and put it here in present. It's done. So you have the file now. So once you have the file, what you have to do, we need to execute this. We'll say so what we have to say here. Which one? I think we have written example number 12 now. So we'll hyphen playbook example number 12 hyphen I slash etc slash ansible slash host hyphen hyphen. I'm doing a dry run first of all. Okay, our names are incorrect. Huh? So we need to open this file. So we have passed loops of future. Example number 10, that is we written at 9. So we'll open this. That file number is 10, not 9. Try run. Yeah, no errors. Execute. So it will call that playbook and execute. So that is the use of this roles case. Now, coming back to the further in the concept, okay, it will execute. It will take its own time. So that's fine. But now further going into the concept is Ansible Galaxy. So there is an official site maintained by the Ansible company. So we call that as an Ansible Galaxy. Okay, so this is what the Ansible Galaxy site is. Now, what is the use of this site? So in this site, which is maintained by the Ansible company or Ansible, you can say. So this is a place where most of the people like you and me who are interested in books can upload here. Like in the college days, we used to upload some PDF to some third-party sites and they can share it, right? So likewise here. So this is something like a community website maintained by the Galaxy, where if you have written any playbook in a reusable format, and if you are willing to share, I repeat, if you are willing to share that to the community, then I'll go and come to this place and share your playbook. And that playbook should be written in reusable format. Somebody like you and me may come here and search such playbooks. For example, think about a use case where I'm not aware on how to write the playbook for SQL. Imagine they told me to set up entire SQL. So I do not have any clue on how to handle it. So what I'll do, the best suggestion is come to the Galaxy and search with some keywords SQL. Okay, see, you found some playbooks written here, which are written by some users who are already registered in this site. And you can click on it and see the code how it is written. So once you come to this site and you have this option here, guys, somewhere around here. So in this, you have to go to this option. And it is a responsibility. See, the details tab is there, readme tab is there, content tab is there. So in this tabs, you'll have some information. What is this playbook and how this role has been written, how it is being used. So it is a responsibility of the person who has uploaded here to give the clear documentation on the use case of the playbook. Otherwise, you have to search yourself and learn yourself and explore. But some users will be very nice and they will be happy to document everything super clear here. Now let's go to the repos here and see where the code is sitting. So I clicked on it. It came to a place of GitHub where you can see now entire code. So how it has been written. Okay, so you can go to, let's say, let's imagine just I'm going to the default. They have written some prepare.yml. Some SQL codes they have written. Sorry, this playbook codes. Got it? So here, the basic purpose of the Galaxy site is to make sure that if you are not aware of any of the code logics, how to write it, the best place to search is Galaxy. So Galaxy is a community website where the people who have written already the code on the some codes on the playbooks, and if they are written in reusable format, so come to this place and check it. You may help or it may helpful for you because at least you'll get a clue on how to write it. Clue, guys, that's a big advantage for you. So Galaxy site is like a clue. Even if you do not find answers in the clue site or let's say Galaxy, we are left with no option. Definitely you need to Google it and find out and do or adventure upon your own intelligence. So got it? So this is purely a website maintained by Galaxy, maintained by Ansible. The site is Ansible Galaxy, and it contains community written playbooks, which are in role format. So that is a use of Galaxy, guys. So this is all about the Ansible stuff. So did I update the notes yesterday, guys? Okay, so let me update 31B. So our next biggest tool is Docker. Docker is one of the tool that you should have in your resume, guys. So let's give me a few minutes. We'll go to the Docker. Okay. Now coming to the Dockers, very important thing. So coming to the Dockers case. So what is the story of the Dockers here? What is the story of Dockers? Any idea on what is a Dockers first of all? Any idea about Dockers, guys? So if you want to claim that you are a DevOps engineer, so this is how you need to have Linux knowledge, version control system, CI/CD, right? Configuration management. Now containerization tool, and next orchestration tool, guys. So these are the, I would say, like Linux is your hand, or you can say paw, and these are the 5 fingers. So paw and 5 fingers, then only it makes DevOps. Monitoring is least. So don't try to do engineering work on monitoring. But another biggest thing you need to keep focus is shell scripting, which we'll see after Kubernetes. So shell scripting is one more area where you need to go hand to hand. Now let me go ahead and focus on containerization. Any clue on containerization, guys? So Docker comes under the concept of, so please take the points, start taking the points. So Docker comes under the concept of containerization. So what is this containerization? So if I talk in simple words, containerization is all about bundle. English words I'm writing first of all, then we'll see technical. So it is all about bundle an application, okay, with its dependencies in a containerized format. That's it. So simple. It's all about bundling an application with its dependencies in a containerized format is called containerization. Again, there the word is called containerized. So what is this? A deck, trying to understand. Or I'll give one live example so that you'll catch. Example. So best example is, so let's say you're traveling to, let's say, village. Okay, imagine you're traveling out of town or some village or some vacation. So now the question comes is, will you carry entire home with you, or will you carry the items with you which are only required for operating 4 or 5 days? Maybe let's say you are going for 3 or 4 days on vacation. Will you keep or will you carry entire home with you, or will you just pick up the items which are required for you? Tell me, guys. We just only keep the items with us which are required only for 3 to 4 days. Makes sense? You're understanding what I'm talking, see? So an application is only carrying its required stuff. That's it, nothing else. So that is what we are about to see. So in a simple example of a village or a vacation. So when you're traveling on a vacation, we don't carry all the items of your home with you and keep, take with you. So we just pick up only the items which are required to survive only for 3 to 4 days. That's it. So that makes sense for this. So now let's see this containerization, okay, is an outcome or containerization technology. First of all, this is a technology, guys. So this technology is an outcome or an output because of failures in VM, virtualization architecture. So that means you need to understand the story from virtualization. So if somebody asks why the India is still a developing country, so definitely we have to look into the history, correct? So if you are trying to understand why the person became so sick, then definitely we need to understand his medical history. So likewise, the history behind the containerization is virtualization. So virtualization, if you understand little flaws, then easily you'll be able to understand containerization, guys. So let's see. If you're talking about virtualization here, please write the points. So Virtualization technology came back in 2000 year, guys. 2000 year. That's the first point. And this technology is one of the revolutionized technologies of IT. Like web server is one such technology, right? Operating systems like Windows and Linux are also revolutionary. Likewise, virtualization is also revolutionary. Okay. So virtualization made possible that using single hardware, using single hardware, we can boot multiple operating systems. Prior to 2000 year, it is not possible for us to boot multiple operating system using a single hardware. So that was a drawback, or that is how the invention happened till 2000, right? Got it? Yeah, what is this? UAT deployment. Now, yeah, just give me a minute, guys. Let me reply to that. Okay, we can give that reply later. The virtualization came back in 2000 year, and single hardware cannot be booted. But what this technology has done is, so using this technology, it made possible that we can use single hardware to boot multiple operating systems. Okay, so that is nothing but your virtualization. Correct? So it is possible that we can use single hardware, right, to boot multiple operating systems. So if you see the architecture wise, it looks like this. So you'll get your base hardware, right? Base hardware means base machine. Upon that, you will implement VM architecture. And using VM architecture, you can create clusters of operating systems. In a single VM box, you can create clusters of operating system. So upon each operating system, okay, upon each OS, we can load our app, whatever you're looking for an access. So that is how the architecture looks like. So I repeat, so using a single hardware, we implement VM architecture upon it. And upon setting up the VM architecture, we can create clusters of operating system. So under each cluster, we'll set up an operating system, and upon that, we'll set up application. Now, on the machine where we are trying to set up the entire architecture, so that machine generally in this technology, we refer to as VM machine. Full form is virtual machine, guys. I repeat, on the machine where you're trying to implement this is called VM machines. And the softwares that help in implementing this architecture, or you can say this kind of an implementation, such softwares we can call it as, any idea, guys? What is that softwares? Any clue? Any people from virtualization background? Is it cloud? Open source? No. So it is called hypervisor actually. So like for antivirus, we call antivirus softwares that deal with what you can say the viruses like backup. They talk about DB softwares, right? Database backups softwares. So likewise, if you're talking about editors, we have editing softwares a lot. So likewise, there is a special category here. So the softwares which help in implementing the virtualizations or VM architecture implementations, we call them as hypervisors. Clear? If you hear a word hypervisor means that's a software which helps you to implement VM architecture. So that's a special word came up in the industry. Now, please take down one more point. Virtualization architectures are of two types. Okay. So VM architectures are of two types, guys. So type number one, please write it. So VM are of two types. So this can be very dangerous for interview also, because if you give the wrong answer in this type, then you are easily caught that you are fake. Got it? So those who want to go with little fake experience, you should be very careful with this question. So first type is called hosted architecture, and second type is called bare metal architecture. Okay. First type is hosted architecture, guys, and second is bare metal architecture. So only two kinds of architectures are there here. So hosted architecture and bare metal. So what is this first one? So hosted architecture. In the hosted architecture, here you will have a machine. Upon the machine, you are going to install the operating system. Upon the operating system, you are going to install hypervisor. Upon the hypervisor, you are going to create an OS. Upon the OS, you are going to install your app. So this is how the architecture looks like. So you need to imagine like a building. So ground floor is a machine, first floor is a OS, second floor is an hypervisor, third floor, I mean to say next floor is OS, upon that application. So generally the hosted architecture, the best example is currently what you are practicing. So just see, I am using Windows 8. Just see, I'm writing. So I have my laptop. I write the equation now. See, I have a laptop. That is nothing but my machine. On my laptop, I have my Windows 10. See, the second equation came. Upon my Windows 10, I have installed my Oracle VMbox. See, then upon Oracle VMbox, I installed Linux, and we were practicing with app called Ansible or a Git. Make sense, guys? Understood? Equation, did you understood first of all? So this is called hosted architecture. So it is called hosted. The reason is VM software. So this part is called hypervisor actually, right? Oracle VM, whatever you're trying to install, that is nothing but hypervisor. So this hypervisor is setting on upon your operating system. So that is a premises. So hypervisor sits on OS. So that is a premises. So this kind of architectures, basically these are non-production grade. I repeat, these are non-production grade, and these are, so I repeat, these are non-production grade, and these are generally used for lab practice, guys. Lab practice. That's it. As simple as it is. So are we using that Oracle VMbox? Which one are we using? Can I say that we are using hosted architecture? Yes or no? So we are practicing on hosted architecture only. So don't give this example in interviews. If you say how you use Ansible in a real time, if you say that I'll use Oracle VMbox, upon that I'll install Ansible, gone. Because that is what, that is non-production grade. That is to experience the how the VMbox. Got it? So this is non-production grade. Now coming to the production grade. So let me remove this and let me write it. So second one is all about bare metal architecture. Please write this. Bare metal architecture. In the bare metal architecture, you will have a machine. Upon the machine, directly you will install hypervisor. And upon that, you will create a cluster. That is important. You will have a cluster here. Cluster. And in that cluster, that means in a cluster, we'll create an OS. One of them can be an OS. One. See, cluster means a group of collections, guys. So group of operating systems will create. One machine will use, let's take it one. Okay. In that OS, we are going to install our app. So this is how the equation sits like. So machine directly hypervisor. That means between the machine and hypervisor, there is no OS. So whatever the hypervisor that you are going to use here, you need to buy it. That means we have to use licensed copy of hypervisors. Clear? So licensed copy of hypervisors are there. So whatever you're using Oracle VM box, that is free of cost. We just downloaded from internet and started using. That is free of cost. But if you're talking about the bare metal, that's the reason it is called bare metal. Bare metal. So directly we'll have a machine. Upon the machine, there is no OS. As good as you just got a plain laptop, purchased a plain with no OS, no operating system. Directly upon it, we'll install hypervisor and then we create a cluster. And then in the cluster, once set cluster is set up, then we create an OS. And then upon it, we'll set up app. So this kind of architecture implementation, we call it as bare metal, and this is a production grade. This is a production grade. So I repeat, bare metal architectures are used in real times. Okay, for example, if you go to a shop, let's say computer shop, and when you ask them, let's say I want a laptop or a, let's say, desktop, don't you face a question asking that you want a plain laptop or you want a laptop with Linux or you want laptop with Windows or you just want only a laptop, no OS, no operating system, right? So I'm talking about a use case. It is called bare metal. That means nothing, no operating system installed. So we just get the bare, and upon that we directly install hypervisor. Hypervisor is not free. We need to buy the license, okay, from a particular brand. And once you install it, then we have to create a cluster, upon it OS, then upon that app. So this is a real-time architectures. And you know who brought up this hypervisor, or I can say this virtualization technology to the world? Who is the leading player in the virtualization? For example, let's say if it is cloud, we say AWS, right? So likewise, if it is operating systems, we say Microsoft. And if it is virtualization, it is VMware company. So VMware is a brand here, which brought up virtualization to the world. It's clear? So VMware brand is a king in this business. Like in CI/CD segment, Jenkins is a king. In the hypervisor business, VMware is a king. Correct? So that's all about the two types of virtualizations. Now, keeping this in mind, we have to know what went wrong now, because you just came to know how to use this. Now we'll talk about what went wrong with this, guys. That is where containerization started. So the end story looks like this. So app sits on operating system. Do you agree? End story, whether you take it type 1 or a type 2. The end part, conclusion part. The app, if you want, then technically you require an operating system. So app sits on OS, whether it is a type 1 or a type 2. So that's a moral. Now, when the VMware came to the world, or this technology came to the world, right from 2000 to, let's say, even 2003 or 4, everything was like happy mode. Happy mode means everything was going smoother. Then thereafter, IT industry started facing some troubles about this technology. Troubles started. So, for example, when Kia came into the market early, I mean to say Kia car, if you take. So when it is came into the market, okay, it looks like happy mood only. But until unless you use the car, you will never talk about its troubles. Correct? You take it any brand, it's the same story. So new car comes in, everything will be happy. You start buying, you'll feel okay, it's nice. But after using for at least 2 or 3 years only, then you will definitely have a feedback upon that product, right? So likewise, what happened? There is a feedback started coming on VMware. There are some troubles. So that troubles, out of the troubles, they were looking for some solution. and that solution is nothing but gave birth to the containerization. So that is where the story of Docker started. So now let's see the troubles. Trouble number one. So we'll talk about couple of troubles. Trouble number one. Okay. So definitely to host a even small app or a medium size app or a large size app, whatever it could be, any size it could be, small, medium, or large size of apps, definitely it has to sit upon an OS. Do you agree? That is what we cannot host it on, let's say, on air or right. So the technology is in such a way that we have to make it to sit on operating system only, whether it is small, medium, or large size kind of an application. Now this underlying layer, right? The underlying layer is what? What is the underlying layer, guys? Here, what is the meaning of underlying layer? So can I say it is nothing but your operating system? The underlying layer is operating system here. Correct? The application is sitting upon the OS, so the underlying layer is OS. Now in this OS, somebody questioned to host a small application or a small things, one application, why we have to use the entire operating system. In this entire operating system, you'll have a lot of junk there, which we never use. See, example, just take an example, my use case. We are using Windows 10, okay? So maybe let's take it for granted a businessman only uses MS Word. His target is to use MS Word only. Just take an example of a shop. His target is to use MS Word, Excel sheet. Now, when he goes with Windows 10, okay, from the shop, he gets Windows 10. Then when you go into his applications, you will see like Get Help, this Groovy Music. What else? This Maps, Mails, right? Microsoft Store, and this OneDrive, this Paydi, what is this Paint 3D, PC Health Check, Phone Link, Photos, Skype, this playing games. All these apps are not a demand for me. Do you agree? You understood in that simple example, guys. So let's say you went to an hotel and you are trying to order a meals. Let's say South Indian thali or a North Indian thali. Whether you like it or don't like, he will give you all the items. Correct? Yes or no? So whether you like it or you don't like it, you get your plate with all the items, whatever he is serving, whether North or a South thali. So that is what I am talking. So this underlying layer, whatever you choose in, so it is containing some applications which we never use at all. So that means we are trying to host for a small things. Also, we are trying to use full-fledged operating system, and that underlying layer, along with an my application, I see a lot of unnecessary junk. So that is the first problem. Second problem, if I'm using unused or unnecessary things, right? So definitely, can I say they consume my space? Do you agree? Or I can say it's a storage, right? See, some applications are sitting for no reason. I don't know for what purpose they are sitting. So they're consuming the storage. So this is a second headache. Third point. So you will see some apps booting, okay, during the boot process, and they are running behind the scene. Am I correct? They are running behind the scenes, and definitely you don't use that application. For example, you just right click here and just go to this task manager, and you just see the items here. I'm talking about this stuff only. So you may see some applications which you never know for what reason they are running. Am I correct? You got it the point, guys, what I'm talking? So the applications are first of all sitting on my computer. Second, they are eating away my storage. Third point, they are booting. That means they are becoming chalu, or you can say they become active when you log in, and they are running behind the things, which first of all, we don't use that app, but still they are running. So that is a third challenge. And if they are running, definitely they'll eat away your RAM. Correct? So what they are eating, or you can say they are consuming. Consuming what? Your CPU utilization, and also they are consuming the RAM. So this is another headache. Fifth one is finally, if you have some process, if it is or something I told you now behind the scenes, if the process is running without a user knowledge, what is it, guys? Without a user knowledge, can I say it is a security threat or a compliance? You agree? Yes or no, guys? That's a simple story. So if any process is running on your computer without your knowledge, then definitely that's in compliance only. If you talk in IT security fundamentals perspective, that is definitely in compliance and a security threat. So these many challenges were there in in VM architecture. One more, the last challenge is RAM itself, memory itself. So one best example is, so let's say you created a Linux VM. Just an example, guys, to make you understand how the memory is getting wasted here. And it consumes, let's say, 1 GB of RAM. You declared 1 GB of RAM, 1 GB, okay? Like we are doing for our practice, correct? 1 GB of RAM. So machine is actually using, let's say, some 512 MB. Let's take it for granted, machine operating system uses 512, right? And my application which I'm hosted may be using some 100 MB only. Got it? Just an example. So my application which I'm trying to put it on my Linux VM, maybe at maximum capacity it uses 100 MB of or 100 MB of RAM. So in total it is roughly 612. Roughly 612. Or you take it for granted, like 700 MB, guys. So granted 700 MB max. So out of, if you minus from 1 GB, how much I'm wasting? Tell me. Can I say roughly around 350 MB of RAM? MB of RAM am I wasting or not? Roughly. Rough, I'm just telling you in rough words, right? So that is one of the biggest trouble in this technology. So VM architectures does not allow you to customize the memory utilizations. So by default, for the OS to run, you have to declare some memory, and whether that OS uses or not, that is secondary. So that is a trouble here. So we cannot customize the memory requirements for our application. So that means there is a wastage of or leakage of RAM utilizations. So keeping this troubles in the mind, so some IT companies started adventuring. So now it looks like a story of gold. We have some smugglers started digging where the gold is, right? So what happened? Some of the IT companies started exploring the solutions for it. They started to think about, okay, how you can fix this. So they were focusing on this. They were trying to explore. IBM invested, Oracle invested, BSD Unix invested, Dot Cloud invested, Google invested. So a lot of multi-billionaire companies, everybody invested. But out of this investment, even VMware also invested. But out of this game, one fellow won the, or first fellow who gave little success is BSD Unix. Berkeley State Distribution Unix came up with some partial success. way back in 2006. Okay. The next big game changer was this fellow, Dot Cloud. Dot Cloud became successful, and he came up with an idea or produced the technology solution in 2009. And whatever the technology solution that he came up, he took a patent right on this and he called it as containerization. So Dot Cloud was a company which produced the containerization technology. They became huge successful in such a way that their product was called as Docker. And in 2013, the company was rebranded as Docker. This is a story. Clear? So the first partial success came from BSD Unix. Thereafter, a lot of other vendors also tried, but somewhere success, somewhere flop story. And the second major contribution came from Dot Cloud company. Actually, Dot Cloud company was from USA. They are into some internet business, guys. Internet business. Okay. So they invested some of the revenue into this IT technology, and luckily they became successful, and they came up with a solution saying containerization. And their product name was called Docker. And today the company also got rebranded as Docker. Got it? So what they said that whatever you are talking, all these things is possible. Okay, whatever problems you listed, all these problems can be solved or solved already. These are solved by implementing containerization technology. So what is this? So this is nothing but, so if I give a simple example, instead of app sitting upon full-fledged operating system, okay, we'll make the app to sit upon only upon its required dependencies. That's it, nothing. So this looks like an example like once upon a time, you used to see a lot of full meals getting ordered, full meals concept. Now today in the hotels, you will see exactly like a plate meals. Do you see that, guys? Trend is changed now. No, I'm talking. You have to understand the scope there. Scope. Yeah, you can say buffet also is a good example. Perfect. So they keep the items before you. You just only eat what is required. Correct? You getting the point now, guys? So in earlier use case, whether you like it or don't like, in either Thali or South Indian Thali, they'll give all the items whatever you like. Whatever they cook, they just send it to you, right? But in the plate meals concept, you only just eat how much it is required. So instead of full meals, we only just eat plate meals now. So that is a good, nice example to make you understand. Or another example, guys. If you're ordering a meals online, the same classic example, you'll get all the curries, whether you like it or not like. But if you're at the hotel, if it is buffet, then you only just put into your plate what you like. So that means you're customizing it, completely customizing, right? Okay. So this looks same exactly. App sitting on wastage of our operating system. In the OS, you'll have unnecessary stuff. So what they have done? So they made the app to sit upon the part which exactly helps you to run the application. Right? So app sitting on full-fledged operating system. In the full-fledged operating system, basically you have all junk stuff little added there. So now the application is exactly sits upon its required dependencies only. So that is the what you have with the Dockers. That's the reason Docker is said. Docker is all about bundle an application with its required dependencies. That's it. Okay. Yep. So that's all for the day, guys. We understood the theoretical part about the containerization, and tomorrow we'll proceed with understanding of further containerization and we'll start dealing with Dockers.